In this video, we'll be discussing blockchain and cybersecurity. This video was brought to you by the National Cybersecurity Training and Education Center out of Whatcom Community College. NCyTE Center and this material is based upon work supported by the National Science Foundation. My name is Philip Kreger. I am a professor of cybersecurity at Embry-Riddle Aeronautical University in Daytona Beach, Florida. So as an overview, we're first going to review the previous video, which was on Fintech. We're going to define the term blockchain. We're going to describe how blockchains work. We'll describe their advantages in contrast to traditional data storage. We'll describe how blockchain can be used in cybersecurity. We'll have examples of industries currently using blockchain technology. And finally, we'll have a wrap-up. The Cybersecurity and Infrastructure Security Agency of the United States government identified 16 critical infrastructures. One of these is the financial services sector, and that represents a vital component of our nation's critical infrastructure. It includes thousands of depository institutions, providers of investment products, insurance companies, and other credit and financing organizations. So previously I used that term Fintech. What does that mean? Fintech is actually taken from two words, financial technology. So this means all the information communication technologies that is now used in the financial sector. And so there's a lot of different parts of Fintech, including things like online payments, the exchange of money, various types of research, online banking, investment, crowdfunding, and what we'll discuss today, blockchain, and where that was first used in Fintech, which was in digital money or cryptocurrency, which you've probably heard about. And if you think about all the apps on your smartphone, you probably have one for your bank and you may have one for your credit card. But these are examples of the use of information communication technologies in the financial services industry. So you've already been using this technology. Or there's different types of payment. For example, Venmo is used to send money from one individual to another. Or there's GoFundMe, which is used to provide funds to people on a funding campaign, or even through PayPal. If you want to know more about Fintech, please see the previous video on an introduction to Fintech and cybersecurity. Now, let's talk about blockchain. Well, what is blockchain? Also, why are we introducing blockchain into a video involving Fintech? And the reason is because the use of blockchain greatly expanded with the creation of cryptocurrency. And cryptocurrency is essentially virtual digital currency. There's nothing paper-based about it. You're probably already familiar with cryptocurrencies such as Bitcoin and Ethereum, and there's about 200 other cryptocurrencies that are now available, and that list is growing. Where did the idea of the blockchain come from? Well, it comes from an age-old concept called the financial ledger. And a financial ledger is a book in which all ledger accounts and related monetary transactions are maintained in a summarized and usually classified form. All accounts combine together to make this ledger and form a permanent record of all transactions. And as you see, the basic parts of a general financial ledger include the date of the transaction, usually an account number, an account name, and the monetary values coming into the account and out of the account. Now, accounting ledgers are typically private. That is, they're not shared with everybody. For example, my bank, Bank of America, is going to share my part of my ledger, the money coming in and out of my accounts, not with everybody, but just with me. So again, it's a private ledger. However, ledgers don't have to be private, and that's where the strength and capabilities of the blockchain come in, allowing for public ledgers. We'll explain that shortly. Now that we know what a ledger is, let's think about a blockchain is a collaborative, tamper-resistant digital ledger that maintains transactional records. Now, if we think about the general ledger, usually we think of a business or a bank and they're selling goods and services. That information is updated in the general ledger, but it doesn't have to be monetary transactions that are tracked in the blockchain. There's other types of information that are well suited for the blockchain, including things such as we have already talked about, financial transactions, but also things like medical records and land titles. But there's many more different types of information that is well suited for use in the blockchain. So blockchains can be either public or private, or permissioned. Public blockchains means that all the public is able to see all of the data in this digital ledger. Private means only certain people, for example, within a company or within a business or with a bank can see the information, or it can be permission-based. That is, people moving in and out of the ability to see what is on permissioned blockchain. So unlike a traditional accounting ledger, the blockchain ledger is shared among all the nodes that are participating in the blockchain. First, let's look at what is a block? Well, a block is just a digital storage unit that holds a transaction. And remember, it doesn't have to be necessarily financial. It could be medical records, it could be land titles, it could be any type of information. And if we look more closely at a block, it has various components, including a block header. It has a hash from the previous block header. It has a timestamp. It has another hash of the block data, and it has block data. Now, I know that was a lot to throw at you at once, but we're going to take this step by step, and we're going to skip over a couple of these pieces. But the most important part of this, the transaction list, is the block data, and that's the data that is the information that is being stored. There's two parts of this block that are important to ensure the integrity of the information within each block, and that is the hash, as you see there. So what is a hash? A hash is essentially a digital fingerprint that is computed from the data. So if we look back here, if we look at that block data, we're going to use some sort of math to calculate a digital fingerprint of that data to ensure that if it does change, that we know that it has changed. Let's look at an example of that. So let's say John paid Alice $100. Well, we apply some math to that, and it computes out to a digital fingerprint, in this case, a hash. That hash is uniquely associated with that content, the John paid Alice $100. Now, let's say somebody comes in and wants to tamper with that block. So what they've done is they've added a 0. And so now John paid Alice $1,000. Well, how do we know that that has changed? If we compute the hash of that, notice that that hash is significantly different from the hash on the left, simply by adding that last 0 to that block. And so a blockchain starts out as a single block, and then chronologically, as more transactions are added, more blocks are added to the blockchain, and they're always in chronological order. Again, recall that blockchains can be public, which means everybody can see the data inside, or they can be private, or they can be permissions. But regardless, because blockchains are digital, they're going to be residing on computers. Each computer that is part of the blockchain is called a node. So we have a single computer, but it doesn't really do any good to have a single computer holding a blockchain. We need many computers to ensure the integrity and trust in the data. So here we have a number of computers, and notice that each one holds the same set of transactions residing in the blockchain. And because each of these computers is sharing changes within the blockchain, this is a decentralized peer-to-peer network. Now, I didn't show all the different combinations of connections between the computers, but suffice to say, every computer in there is connected to every other computer, and we call that a peer-to-peer network. Now, let's say we have this blockchain, and each of the blocks has been validated thus far, and I'll talk about the validation process shortly, and we want to add a new transaction. Well, before that transaction can be written and then shared, there has to be something called a proof of work. What is a proof of work? So the proof of work is a cryptographic puzzle that has to be solved and then verified by other nodes before the data is written to the blockchain. That is, it's verifying that that is a valid transaction. So the puzzle requires computational power and is somewhat difficult to solve, but is very easy to verify. So in this instance, we have the little graphic there that has a simplified, very simplified cryptographic puzzle. All the nodes that have the residing on the blockchain are provided that puzzle. And so here we have our super simple cryptographic puzzle, and once one of the nodes successfully calculates this, then that solution is sent out to all the other nodes, who then are able to verify very quickly the fact that that cryptographic puzzle's solution. Once that's done by at least 51% of all the nodes, then that transaction is written as valid to the blockchain, and then the blockchain is updated again through all the other nodes. And so now, that last transaction, as noted there, John paid Alice $100, is considered valid given the proof of work and the hashes involved. Thus far, you probably see that blockchain seems awfully complicated. Is it really a big thing? Is it being used a lot? Well, at least in the financial services industry, it is. For example, 91% of banks had invested in blockchain solutions by 2018. 66% of institutions expect to be in production and running at scale with blockchain in the near future. But again, it's not just used in banks. Blockchain is useful for any type of information that needs to be trustworthy. So what are some of the advantages of storing information in blockchains rather than just in simple old databases? Well, there's a number, including an increased trust. As a member of a private blockchain network, users are assured that they're receiving accurate and timely information and that confidential blockchain records will be shared only with network members to whom they have specifically granted access. There's also greater security. Consensus on data accuracy is required from all network members, and all validated transactions cannot be changed because they are recorded permanently. No one, not even a systems administrator, can delete a transaction. And finally, blockchains provide for efficiency. As a member of a private blockchain network, time-wasting record reconciliations are eliminated. Smart contracts, which are a set of rules, can be stored on the blockchain and executed automatically, resulting in efficiencies. Now let's look at some blockchain applications in cybersecurity. Before we do that, we need to revisit the properties of information that we need to secure. And I've already covered this in a few other videos, but let's look at it one more time so that everybody is clear as to the important properties of information. The first is confidentiality, the second is integrity, and finally availability. And we call those the CIAs of information security. So in terms of blockchain and confidentiality, the National Institute of Standards and Technology defined confidentiality as the property that its sensitive information is not disclosed to unauthorized individuals, entities, or processes. That is, it's kept secret. The idea of the blockchain originally didn't provide for confidentiality. However, some implementations now are geared towards cybersecurity and have added things like authentication, access control, and encryption to promote confidentiality of data stored in the blockchain. For those of you who are unfamiliar with authentication, access controls, and encryption, in the description of the video, I'll provide links to videos I've created before that explains those concepts. Confidentiality is especially useful for private blockchains. For example, data that is on intranets, let's say for a bank or for a company that has proprietary information. They don't want to share that with anybody. Therefore, they use blockchain and encryption and other various forms of access controls to secure that data. Second is integrity. And this defines integrity as guarding against improper information modification or destruction and includes ensuring information non-repudiation and authenticity. That is, data as written shouldn't be changed unless somebody is authorized to change that information. And this is one of the key features of blockchain technology. Blockchain enables users to trust that the transactions stored in the tamper-proof ledger are valid and trustworthy. The combination of sequential hashing, as we discussed, that is those digital fingerprints, and cryptography combined with a decentralized and distributed structure makes it difficult for a third party to tamper with it in comparison to a standard database. Finally, transactions added to the blockchain are verified and timestamped, allowing organizations to trace a transaction to a specific time period and identify the corresponding party on the blockchain. Notice that blockchain technology does not guarantee or improve data quality. And so there's an old saying in programming and also in cybersecurity, garbage in, garbage out. That is, just because information in a blockchain has been validated, that doesn't mean that it actually reflects reality. What blockchain prevents is somebody coming in and changing the information within a block after it has been written and validated. Finally, there's availability. And this defines availability as ensuring timely and reliable access to and use of information that is stored. The decentralized and peer-to-peer characteristics of blockchain technology make it more difficult to disrupt than conventional distributed application architecture such as client-server. However, distributed denial of service attacks, or as we call them DDoS, still require adequate protection measures both at the network and the application level. Ethereum and Bitcoin cryptocurrencies have been subjected to DDoS attacks in the past, as recently as 2014. So although more resilient than current database technologies, decentralized blockchain solutions depend on high availability and DDoS attacks will remain a persistent threat. So I know I've mentioned DDoS attacks in here a couple of times. Let's see what those look like. Up in the upper left-hand corner, we have our victim, our single computer, and on the bottom right-hand corner, we have an attacker. And then you see running from right to left is we have these blocks that say IoT. These are Internet of Things devices. And the reason I've selected those is because Internet of Things devices, such things as security cameras and any information communication technologies device that connects to the internet is essentially an Internet of Things device. And that includes things like phones and smartwatches. But as it turns out, a lot of IoT devices, usually the cheap ones that are sold online, don't have great cybersecurity. So a concerted attacker is able to take control of those IoT devices and use that for his or her advantage. So let's say that a bad actor now is able to control 10,000 all the way up to 100,000 Internet of Things devices. And by the way, those numbers are not an exaggeration. That actually exists. These are called botnets or bot networks. And so once the attacker has a victim in mind, it sends out an attack order to each of the IoT devices, which then sent an overwhelming amount of network traffic to the victim. And essentially, it overloads the victim to the point where the victim cannot respond. And by the way, these attacks are carried out every minute of the day all over the world. And at some point, the data traffic coming into the victim so overwhelms it that it is unable to respond, and therefore data can't be shared, data can't be consumed, data can't be contained. But if we have a peer-to-peer decentralized network, let's say one of these computers is taken down by a DDoS attack, let's say another and another. Well, what does that leave us? Well, it leaves us all the other computers on the network. So having a peer-to-peer decentralized network does provide some form of security against distributed denial of service attacks. Now let's look at the industries that are using blockchain technology. Other than the financial industry, we've already gone over that. One example of where blockchain technology is used is in the healthcare industry. Healthcare agencies and organizations have faced significant issues including interoperability, privacy, and supply chain traceability even before the COVID-19 pandemic. Proprietary electronic health record systems from more than 700 vendors routinely are unable to exchange information, which is a major challenge. In the U.S. alone, there were 1,750 incidents of drug counterfeiting in 2018. Blockchain has already demonstrated its value in healthcare and the life sciences by enabling trust and collaboration during the COVID pandemic, mitigating issues such as interoperability, privacy, and supply chain traceability. Blockchain has also started to be used in manufacturing. Manufacturing stretches across the world to best exploit the availability of raw materials, labor, funding, and consumer markets at the most competitive rates. A single critical link in the supply chain can test the resilience of the entire operation because companies are bound closely together by long international chains of supply and demand. Blockchain enables trusted data exchange and workflow automation across organizational and national boundaries, helping to strengthen fragile supply chain and trading relationships that have been ravaged by the pandemic. Blockchain facilitates more ethical consumerism also by tracking the provenance of components and manufactured goods. And the final industry we're going to look at is travel and transportation. Human travel by airplane, ship, or train, as well as cargo transportation, requires a trustworthy method of keeping track of a host of activities, assets, goods, and people. Verifiable, authenticated data is necessary to support business operations such as ticketing and billing, and to support customer satisfaction with on-time service and reliable baggage handling. Blockchain digitizes transactions and stores information on a shared ledger, enabling participating companies to share information in a climate of trust and transparency. The large shipping company Maersk, which is a global leader in container logistics, have streamlined shipping with an efficient, secure global trade digitization platform based on blockchain. If you want to hear a very good explanation of how Maersk as part of the supply chain was decimated by a cyber attack, please look at the Maritime Transportation System videos that I've created and uploaded to YouTube. So in summary, we found that a blockchain is a collaborative, tamper-resistant digital ledger that maintains transaction records with transactional records, that is data, that are grouped into blocks. While a traditional ledger contains monetary transactions, these blocks can store any form of information that requires integrity, availability, and even confidentiality when necessary. Blockchain technology promotes trust, transparency, data integrity, and possibly data confidentiality, all important attributes of information which we desire to secure. Blockchain is currently used in thousands of diverse applications, from supply chain to healthcare to government and transportation. And it should go without saying, based on what I've seen the last few years, blockchain use will continue to grow in many industries. This video was brought to you by the National Cybersecurity Training and Education Center out of Whatcom Community College.